Yeah, very good day. So today we are going to see about electric vehicle, which comes under unit 1. Okay, so we will start with our presentation. So electric vehicles are nothing but a vehicle powered by entirely or partially by electricity. So source of electricity is from battery. Okay, so battery is being used to drive the electric vehicle entirely or partially. Whereas in internal combustion engine, vehicle is really propelled by using gasoline or diesel. It is like petrol or diesel. EV use an electric motor and batteries to propel the vehicles. So when you look into the types of electric vehicle, we call it as battery electric vehicle, which means it is fully electric vehicle. It doesn't have any internal combustion engine. And the examples are like latest Tesla and Nissan Leaf. All this comes under entire battery. There won't be any internal combustion engine in it. But whereas the next one is plug-in hybrid electric vehicle. These vehicles have both electric motor and a gasoline engine. Okay, they can be charged via an external power source. See, when you say the word plug-in, means the battery inside the vehicle can be charged with the help of external source. If they say generally an hybrid electric vehicle, then it means either you can charge or there is no need to charge from external, it will get charged internally itself. So limited in electric range before switching to gasoline. So when we go for hybrid, we will start and we will run the vehicle with gasoline, and at the time of starting, just at the speed range from 0 to 10, we will use it in electric mode. Then we will move on with gasoline. Basically, higher fuel is consumed only if the body is starting from the rest. To come out of the inertia, you need to give an high gasoline. So what we do is, we at that time we will switch into electric motor. Then when the vehicle starts to get speeden up, we will move on to internal combustion engine. Then third one is hybrid electric vehicle. Here it combines the internal combustion engine with the external electric motor, but they cannot be plugged into external charging. This is what I told. You have a battery, but that battery is being charged by the regenerative braking. This term is a little bit new. So regenerating braking is nothing but, see, when you are giving power to the vehicle, and if the vehicle gets speeden up, and if it is running at a particular speed, suddenly if you want to brake it, then obviously you bring a generator coupled to your engine, and when you couple this engine, automatically speed of the electric internal combustion engine will come down. Simultaneously your generator will generate electricity that will be used to recharge your battery. So there is no need for any external plug point to connect your vehicle. So again, example for this is Toyota Prius and in Honda Insight. Then comes fuel cell electric vehicle. This is in testing stage. The vehicle is not been launched, but there are idea by Toyota MIEEE and Hyundai Nexo. They are planning. Here what they do is, internal of external of combustion engine, they will have electric motor powered by hydrogen gas. So here what they will do is, it is a well-known theory which we are studying for so many days. You will try to separate hydrogen and oxygen from water, and the hydrogen is used as a fuel. Okay, since abundantly we have water on the earth surface, we can go for fuel cell based electric vehicle. Next, let us move on to what and all the basic components present in electric vehicle. So electric vehicle should have a first component is electric motor. Motor of two types, either you have a DC motor or an AC motor. Then battery pack. Battery pack is usually done by using cells putting in series parallel combination. So I will have a cell, that cell I will connect it in series parallel and try to make it as a pack. Okay, the capacity of the battery determines the vehicle range. If you put more battery, then obviously the distance traveled by the vehicle will increase. but weight of the battery will increase. So you have to go in a proper selection of, for this particular model, what can be the maximum electric battery pack we can produce. And the latest batteries used are especially lithium ion. The thing is, why we should know why we are not going with the lead acid is, when you compare lead acid with lithium ion, for the space to energy density, when you say if you use lead acid battery, it is occupying some length, breadth and height with a particular weight. The same amount if you go with lithium ion, the energy efficiency is more, so it occupies less space compared to lead acid battery. Then the third one is charging system. There are some vehicles where onboard chargers are available, so which means you can directly connect it to a 230 volt AC. You don't want to convert it into DC and charge the battery. And there are something like when you want fast charging, what we do is we directly give the DC power from outside so that your battery get charged. So there are two type of charging system is available, by existing with an AC or with the DC. Then regenerative braking as a system that capture some of the energy typically lost during braking. That what I told, when you brake at the time, what happens is the energy from the engine is totally waste. Don't make it to waste, try to convert it into electricity by using a generator coupled to your internal combustion engine. Thereby it converts the rotational motion back into electricity, and that is being given to your battery for charging. We should know there are some benefits when we go for electric vehicle. The first one is environmental impact. Environmental impact is nothing but it doesn't produce carbon dioxide as an emission. Since battery, there won't be any exhaust gas, so it is typically we can say zero emission when we go for electric vehicle. Energy efficiency, electric motors are more efficient than internal combustion engine. EV converts more 90% of the electrical energy from grid to power to the wheels. Whereas when you see petrol engine, when you stand on traffics or when you are in low speed, the amount of energy from the petrol or diesel is not being converted into the required thing. Whereas when you use for electric motor, you will get an high efficiency. Cost and saving, initial cost of EV is higher, but at runtime cost is very less. When it is charging 1 unit or 2 unit for 3 unit to get your 50 kilometers, so running cost is very less in case of EV, whereas initial cost is high. But now since revolution is going on, more and more competitor will come near soon, thereby your charge will come down. Then when we see with respect to performance, EV are known for their smooth and quiet operation. Since there is no any internal combustion engine, there will be any sound, and it will be very quiet, and it is also very smooth in acceleration. Innovation, this is where we have to concentrate. Research can be done to maximum extent when you go for electric vehicle. The scope is for all the departments like EC, they have scope, electrical engineers, they have scope, computer science engineers, they have scope. See, for example, when you go for autonomous driving features, EC has a greater scope that all sensors can be used. And when we go for advanced driver assistance system, we call it as ADAS. In that case, IT and computer science people will have more tasks to be played. So when you talk about innovation, there is a lot of innovation awaiting in the field of electric vehicle. Range anxiety, the thing which is we required is when you charge, it runs for a particular time, again it takes some time to charge, and this is comparatively very more when you compare to internal combustion engine, where there you go to fuel bunk, you fill the entire tank within 5 or 10 minutes maximum, whereas here you require at least 20 to 30 minutes you have to stay in the charging station for charging. So that is where we say range anxiety, how to going to increase the range so that waiting time will come down. Charging infrastructure, it has been developing at a faster rate. Now even you will get a renewable energy based charging infrastructure like using solar and thing, but you have to place it in more numbers in highways, thereby if any electric vehicle is there, they can charge it when they are traveling at a longer distance. Then battery life and recycling, You have to always charge your vehicle only if the battery is at least less than 10%. You should not put your battery at charging when it is in 80, 70 or 60%, because life cycle of the battery is fixed. So for example, if we say 1000 life cycle, you can 1000 times you can charge and discharge, but when you do properly the amount of time, then automatically your efficiency will increase. So you put your vehicle for charging, wait till it reaches 80 or 90%, again you put to charge only if it is less than 10%. Thereby you can increase the number of kilometers. And when you come to recycling, it is a very big task how to dispose this battery, because disposing battery is dangerous to environment. We have to see it. Initial cost, nowadays since there are only few number of vehicles manufactured by few companies, if the number of company increases, automatically the price will come down. Let us move on to history of electric vehicle. The thing is, electric vehicle is not new. It was been in 1800 itself we have electric vehicles. Then we moved from electric to gasoline. Again now we are moving from gasoline to electric vehicle. The reason is, in olden days, electric vehicle where you don't have rechargeable batteries, so initial cost put it, then you cannot charge your vehicle, again you have to change the battery. And initially electric vehicle started with a very low speed, so like a queen inside the palace or king inside the palace, they used it. When you come out of the palace or when you come out of any government place, then the road facility itself is not there at that time. So it is only mud road, not your tar or cement road. So driving an electric vehicle in that particular road types, it is difficult. Whereas when they moved to internal combustion engine, they run at a faster speed. Road is not the matter. So when the year prolonged from 1800 to 1900, all we are moving at a very faster rate. So we moved to internal combustion engine. And again now, since gasoline like petrol and diesel is not available in plenty, so obviously you have to go for another source. So there is now again movement from gasoline to electric. So let us start in 1820. The researchers started with respect to electric vehicle, and the first was in 1828 in Hungary. Their first small scale electric vehicle was designed. They designed a basic model modified vehicle powered by non-rechargeable batteries. That is what I told. Initial days we don't have rechargeable battery, so it was not rechargeable. You can buy it, put it, use it, again you have to change the battery. Then in 1935, by a Dutch, built a small electric car in Netherlands. The vehicle used non-rechargeable battery and had so many electric issues. Then followed by 1979, this you have to remember, this was the first experiment with the electric vehicle and introduced first electric car with a partial design. So on road, this was the first vehicle which is brought. Edison's work focused on improving the electric battery also. So in 1989, in Austria, created the P1, an electric vehicle that could reach top speed of 22 kilometers per hour. At that time it was a greater achievement. It was the one of the earliest example of fully functioned electric car. So I told no, in 1879 by Thomas Edison, a commercial car. This was the commercial car where you can see all the batteries are placed at the front. And I told no, in 1889. So this was at 1889 they developed a car which was able to run 22 kilometers with a passenger backside. Again the battery back is provided here. Then in 1980, that is late 19th century, saw a surge in electric vehicle development, and William Morrison introduced a electric with a 6-passenger vehicle which was commercially successful at that time. So this was that particular vehicle. So it is a 6-passenger vehicle, so 2 can sit and there will be a driver, and this was introduced in 1980s. So in 1897, London Electric Cab Company began operating the electric cab, offering a clean alternate to horse driven carriages These cabs are popular due to the quiet operation and a smooth ride. See, when you see horse cab, you will have a jerk, more jerk there will be due to your horse running. So this was that particular London electric cab. So it is like an auto. You can see it is like an auto. Driver sitting here, the passenger will sit inside, and this worked like a cab in London. Then rise and fall. So in 1900, electric vehicle gained popularity in earlier 20th century. Electric car was seen as a clean and easy to drive, with models such as this Detroit electric car providing successful. Then in 1912, invented an electric starter motor now comes into picture. So in 1912 and all, internal combustion engine came. You have diesel and petrol, but the thing is you cannot start the engine. You have to put a crank before the engine and you have to try to rotate. This is what we even now we do in agriculture motor and all. You might have seen there will be in a diesel engine where you will have a rod on front side. You have to rotate it till the engine start, and then automatically engine will run. So manually you have to rotate and start. So in 1912 and all, internal combustion engine was on road, but the thing is internal combustion engine has to be started with a rod connected on the front side. So what had happened in 1912, rather running a electric vehicle running by electric, they used this battery to start the engine. So this was done in 1912. So this we have to remember, this was the first in an internal combustion engine started by a battery was being done. So this was that particular car which was run by gasoline and started by, which we call nothing but a self motor. So self, nowadays we have in our two-wheeler we put a key, we have a button to press. When you press that button, a small motor will be connected to engine and it will try to start. Okay, so these were the two cars that used the battery for starting, only for starting purpose. Next, in 1920 there was a decline. This decline is because now roads and infrastructures are being developed, so we require now more faster way of communication. Since that electric vehicles were running only at 20 kilometers or 25 kilometers, that is not sufficient for us, where we require 60 to 70 kilometers speed. So electric vehicle starts to decline. The popularity of electric vehicle as a gasoline car become more affordable in practical, and the cost of the gasoline vehicle has come down. So all they move on to gasoline, and totally electric vehicle loses its popularity. So in 1930 to 1950, during the mid 20th century, electric vehicle were largely forgotten in favor of gasoline powered. So until 1930 to 1950, even we can say everyone has forgotten that there's an electric vehicle itself, because they move on entirely to internal combustion engine. Okay. Now again a renewal process. What happened is now there is no availability of more petrol or diesel, so automatically again we are forced to move towards electric vehicle. And now in 1970 and all, we have done a huge research on batteries. So again it was a restart. So in 1990 CARB introduced a stated emission regulation, sparking renewed interest in electric motor vehicles. Company like GE, General Motors, introduced with an EV1, a pairing electric car designed for modern market. So this was that electric car. So in 1996, General Motors has developed an electric car, and which we call it as EV1, where very mass production has been done. And this is in abroad. India at that time we are not ready. We have even a surplus petrol and diesel. So now let us move on to modern era. Modern era is nowadays. So we call it as 2000 present. So in 2000, technical advancement led to significant improvement in battery technology. Charging infrastructure has developed. Various electrical high efficient motors are developed. Now the company like Tesla emerged as a major player in EV market. In 2008, Tesla company introduced the Roadster the first highway legal electric motor to use lithium ion batteries. When you say lithium ion batteries, they are chargeable and they are high efficient. So in 2010, Nissan launched a Leaf. This was very successful model from Nissan, the first mass market electric vehicle. So these two vehicle which is released in 2008 and 2010 are produced in larger amount, which means mass production has been done in electric car. When you move on to 2010, government worldwide began to offer incentive for EV purchaser. So how you will increase the purchaser? You have to reduce the tax on electric vehicle. You have to give so many incentives, and you have to talk about this, and you have to bring more investment into this. All this been done. Then BMW, Ford, Volkswagen expanded their electric vehicle offerings. So in 2019, Tesla released Model 3, became one of the best selling electric car globally. And in 2020, major market announced plans to transition to electric vehicle. Company like Volvo, General Motors, Ford committed to producing a significant electric vehicle into the market. So in 2020, which is present, now the situation has little bit changed. Now what happens is, so you take a Phoenix Mall. Inside a Phoenix Mall, if everybody is coming, let us assume they are coming by electric car, so they will park it in the parking slot. Now at a certain time, if the EV requires high power, what can I do is, at that particular time all cars are only parked in my parking slot, not been used. So entire car parked batteries can be put together and made as a one single power source or like a generator. So for any sudden load, the vehicle battery can be used to deliver the power to the TNEB. So that we call it as V2G, vehicle to grid. There is more scope for computer science engineers here. So how you are combining, how you are get the what is the various battery level, and put together to form a grid, and then you transfer this to the grid if any sudden load is required by TNEB. Thank you students, thank you for listening. So this is with respect to your introduction